So welcome to the talk called SharkDump, network analysis using tcpdump and Wireshark. Welcome to PhreakNIC. So there are a few new faces in the room, so I'm going to go ahead and just introduce myself again to people who haven't seen me speak already. My name is Drew. I live in Atlanta. I've worked in enterprise and startups, usually with networking or infrastructure stuff. Most of my background on this talk is going to come from my old SecOps days when I did managed IDS, IPS stuff. I'm here representing myself, not my employer, so if I talk about any work-related things, please forgive the intentional being vague about that. This is my first PhreakNIC still, but this is now technically my second time giving a presentation since I gave the last one in this room. Forgive any nerves I may still have, any jitters, and while I'm trying to figure out, I have no idea what I'm doing. All right, so this is probably going to be a little bit more of a beginner's talk. So I just want to do a quick overview of the tools, how we get started working with each one, and then we'll go into maybe some basic traffic analyzing, and then being able to use Wireshark and tcpdump together, as I often had to do. And then some different resources, and I'll leave some time for questions. Oops. There we go. All right. So is there anybody in here that isn't familiar with either Wireshark or tcpdump? Nope. Okay, one hand. Cool. Who's familiar with Wireshark? Okay, tcpdump. Cool. All right, awesome. So just really quickly, for folks who don't know, both tools are network utilities intended to monitor and analyze traffic across a wire, either physical 802.3 or logical 802.11s. So that includes physical, like hard wires and wireless. I'm probably going to use the phrase on or across, directional, on the wire a lot because I'm old-fashioned and resistant to changing my ways. But I do mean both, either physically wired or wireless connections. So with both of these things, you can see IP addresses, the protocols that they're using, ports, stages of connections, such as TCP handshake, anything you really need to try triage or diagnose any networking issues, or learn behavior of network connected systems. They are both also useful for generating or reading PCAP files. PCAP is essentially just a file, it's a binary file, it's a capture of that traffic across a wire, converted to a log, and you can run things live and look at it as it's happening, or you can capture it to read or share for later. So the differences between the two, primary difference is that tcpdump is a command line utility for POSIX systems, Linux, BSD, probably Solaris, and it's included by default in many Linux distributions. WinDump is an open source port of tcpdump for Windows that I've never used, and the commercial version cleverly is called tcpdump for Windows. So conversely, Wireshark is a GUI-based open source software. It works across all major platforms, Windows, Linux, Mac. I've used it on my Mac a handful of times, but I'm a Linux guy, so I prefer to use it in Linux. So getting started, the most basic structure for using Wireshark is to select your interface and then hit the Shark button, and it'll start capturing all the packets. This helps diagnose the most basic of network issues, such as what traffic is being seen, any ARP issues, TCP issues, and you can continue to work your way up through the USI model for that. Once we have more of these details, we can start filtering for addresses or particular protocols to get more specific in our testing. So here is big blown up Wireshark. Over on the far left, you can see that you have your list of interfaces. You figure out which interface you need to do. You click it, and then, as I said, click your Shark button up in the top left. It has all sorts of handy resource guides and things like that for getting started as well that you can read. It's a pretty well put together tool. So here's how Wireshark looks when it's actually looking at traffic. In the top pane, you have the at a glance. It gives you your source and destination IPs, protocol in use, and then a very brief description of the data. And then in the bottom pane, you can see the actual contents of said packets that you can just kind of toggle through and click through on the line. So, in nearly the opposite, tcpdump is pretty easy to get started. It's usually just tcpdump-i for your interface, and then your interface name as it's called by the OS. And then that will capture absolutely everything, including your broadcast and your multicast traffic. I prefer to filter that out because usually I'm not troubleshooting broadcast or multicast issues. So the syntax is cleverly not broadcast and not multicast. You can just kind of tack on there. So here is tcpdump sort of in action. This second line on this screen basically lets you know that there's verbose things. If in case you're not finding exactly what you need, you can set verbose options while you're running the filter. And then the next line kind of gives you your summary of what you're running, which link you're running against, and what the byte sizes are going to be. Subsequently, you have each packet as it goes across with your source destinations and TCP flags, or if you're doing TCP things. And then at the bottom, it'll tell you how many packets you've captured for display, and then how many packets are dropped by your filter. So are you not getting traffic on a wire because it's saturated? That's a thing that it could be. So when you're analyzing traffic, we've highlighted different fields, columns, and everything we can start really analyzing the traffic. For the interest of this presentation, I grabbed some sample PCAPs from Wireshark's website because my home network is very boring. There are some other places that you can find more PCAPs if you really want to get into kind of packet capture and analysis. So what does it look like when we're getting a DHCP connection? I want to compare a DHCP negotiation in both Wireshark and tcpdump so we can see kind of what the difference in the presentation is, but also kind of look and see how we might flex using one over another or using them in conjunction with each other. So here we have our DHCP. We're using standard ports here, so it lists out that we're having DHCP. And then it gives us the breakdown in our summary here of the discovery, the offer, the request, and the acknowledgement, so that we can we know that we have an address on the link. tcpdump gives you a couple different flag options. The top flag option is QNS, so tcpdump-QNS allows you to read the PCAP and then presents it in sort of the gives you the packet view, and then the triple T NNR reading of the PCAP kind of just gives you the simple breakdown of your source and destination addresses and your packet summaries. So DNS, this is probably the one thing that I always end up troubleshooting a lot with tcpdump. We're going to look at a query, but there's something particularly different about it. And if anybody can read the slide, what's different about this DNS request versus another?
Link?
Nope, not the link.
Port?
Port. So DNS, being a fairly standard protocol, would typically run over UDP 53. Here we just have the protocol being acknowledged as UDP, and in our summary it's telling us our destination port is 65.333, and then 65.282. So someone has some port forwarding and port naming set up on their network. Straight DNS request over UDP 53, we would see DNS here in our protocol field. So here's the same packet, or the same PCAP with tcpdump, again, split up with the packet view and then just the quick summary view. Here, in the quick summary view, tcpdump's probably not quite as useful, because while it does tell us that it's UDP, it doesn't, and it tells us what our different ports are. It doesn't flag it as saying like, hey, this is a non-standard port. All right, so DNS and ICMP together. This is probably going to be something that's a little more typical, because if you can't connect to something, why don't you try and ping it? And then if we're having issues with DNS, we're going to see both protocols running over the same wire. This is a simple way to look at a more complex network, because you're going to have multiple protocols, multiple destinations, and kind of all different processes. So here we have ICMP going in our lovely, I guess, magenta-ish color, and then our DNS requests are going to be in our blue color. So this is, super helpful when you're looking at kind of a stacked network that's going to have multiple processes and protocols running, because you can human eye filter out by color, hopefully, and then you can then build filters to ignore any protocols that you're not looking for. If you don't care that ICMP is successful, you can filter out your ICMP packets, and it will give you just UDP packets, or you can just filter down to TCP, and then both of those can be specific protocols as well. So here, tcpdump starts to get a little messy, in my opinion. This is our this is the packet view of tcpdump. It's just like reading any other packet, but when you're looking at multiple protocols on at the same time, it gets a little cumbersome to read. The summary view is a little bit easier to read, because you're able to, with your eyes, read out ICMP or UDP DNS type traffic, but again, you have to kind of filter everything further down than that. So as we're noticing, as our networks become busier, the captures of our traffic become more diverse, and then we need to start really kind of cutting down and filtering on very specific things that we're looking for. And this, eventually, like once you've kind of built your filter, as far as like what you need to look for, tcpdump shines because you can easily craft it via flags and commands. So you can filter, only TCP, only port 80, and everything like that. Wireshark's filters are very strong and have their own strengths, but they're all menu-based. So if you're on the phone with somebody who's like, why doesn't this thing work? To me, it's a little harder to kind of move my mouse around, point and click, and everything like that. However, the fact that you can save all of your Wireshark filters means that if you're having frequent issues or issues that kind of crop up over and over again, you can save those filters and just run the filter each time it happens, and then triage and diagnose the issue. To do the same thing with tcpdump, you would essentially have to write your own shell scripts to do it, which isn't a bad thing. In fact, there's probably some benefits to shell scripts because you can set certain variables that you can just modify every time you need to run it. But it is, a separate script that needs to be, maintained and everything like that. So, like I was saying, once you know exactly what you're looking for, it's really easy to build out this tcpdump filter. So we've got suspicious telnet traffic to our Linux system at the address 192.205.157. So our tcpdump filter looks something similar to this. We're going to filter out our broadcast and multicast traffic. We only want host 192.205.100.57, and then our localhost and TCP port 21. So we only want to see the FTP traffic, or telnet, sorry, and between localhost and our remote host. So this is kind of the mixing and maxing of Wireshark and tcpdump. Being able to use both in conjunction with each other, depending on what you need to do. So if we're building and constructing filters, the first place I would look is using tcpdump. Even though I prefer writing filters in tcpdump, again, having repeatable issues and repeatable usage of filters, I would probably take my written tcpdump filter and then create a Wireshark filter to run on top of, or to run instead. Because again, it is load the filter, hit the button, let the capture work. As opposed to tcpdump, I'd have to remember every flag. The next place I prefer to use both of them together is doing deeper analysis. I like to, again, it's easy to build one-time, one-off filters in tcpdump. And then what I would do is use tcpdump to capture the traffic, create the PCAP file, and then look at that PCAP in Wireshark, just because of the helpful features, such as highlighting protocols, really just kind of like an ease of use at a glance. You can easily save those PCAP files by either redirecting to foo.pcap or doing a pipe foo.pcap, and then take those PCAPs, load them up with Wireshark, and start looking at things in multiple levels at with a single screen view. So as I said, there's some resources. Wireshark is at wireshark.org. Their site has all of your downloads, your documentation, and those sample PCAP capture files, and they have any number of them. I just grabbed some of the simple basic network traffic ones, but they have some other very specific, like, hey, this application does this weird thing, here's a PCAP so you can diagnose whether or not that application is doing that weird thing on your network. The next link is NetResec. And they have a lot more packet capture files. Some of them are a bit more detailed than some of the ones I wanted to go over for this talk. And I will turn it over to any questions. Yes?
With tcpdump, can't you use VPF to filter so you don't have to do your shell scripts?
I'm not familiar with doing it that way, but you might be able to, yes. Cool. Well, thank you very much. Again, my name is Drew. Thanks for sitting in on this talk. You can follow me on Twitter at .SecLab or go to my website, .seclab.net, and get in touch with me there. Really appreciate you guys coming out.